Horse Program is weekly update. Hello, guys. Welcome back to another episode of the weekly update. Today, I'm showing you something that I'm pretty stoked about. I made an old version. I made a new version of an old game called Snake, but I made it for the console app. I'll show you a little playthrough, and then for those interested, I will talk about the coding and how I made this game. So here we go, Snake. All right, that was a look at the Snake game, and here I will try to do my best to explain whatever I did for I don't know how many hours it took to make this. It was a long process with a lot of trial and error, changing the whole way the game worked in the middle because it wasn't working that great. A great learning process, and I will try to guide you guys through it. So, the whole game is contained in a little while loop. Outside of it is a high score variable that can keep track of your high score. As you can see, I have a little to-do list here that I will probably try to implement a file stream for creating a text file on your computer that stores your high score in between sessions. And so the game is contained in a while loop. So basically what this while loop does is print a little menu right here. And let's see if I should do something like this maybe. And it creates a console key info variable that looks that inputs a key. We have a read key over here, and it says that if the read key is spacebar, we will go ahead and play the game. If it's escape, we will break this loop and the program will stop executing. So let's take a look at this function here called play game. As you can see, it returns a integer called high score. And so this is basically where the game is played. We got a lot of different variables for setup of the game. This is a lot of different variables. We're gonna read the keyboard and we will store inputs in a console key variable. We got a random class, which we will do some things with. And we got a score variable. And for the playing field, we have a width and a height. This is set to 15 and 10 right now. You can do it however you want it. And we also have a two-dimensional char array that will be keeping track of the playing field. So we go ahead and make a new char array with the width and height as which will create the length of this variable. For the player, we got some different variables. We got a player is alive bool variable, which will start as true because we are alive for a little while. And we got a string array for keeping track of where our player is. And I call this one player position XY, who will be keeping track of X and Y coordinates for the character. And here we see the first use of the random class. So each time you start the game, both X and Y coordinates are set to a random number between 1 and the width and height -1. This number not included. So the playing field has a wall which you can collide with and die, so it wouldn't be a good thing if and these are stored in the char array. So like the walls will be X and Y coordinates 0 and 1 minus however big the X and Y coordinates are. So you wouldn't want to start in this place. And we put this is like a big part of how I fixed the problem of keeping track of the player. So I will be storing the X and Y coordinates of the player as a string. So here we can see in the string array that is the player character. The 0 index will always be the head, and it will be a string with first the X coordinate as a string with a space in between, and the Y position as a string. Then we also have a velocity array, which will keep track of our X velocity and Y velocity. And the player starts out as with length of 1 and will be growing larger throughout the game. And we also have a speed variable, which starts at 1. And then the last variables are connected to the food that we will be trying to eat. And these are the X and Y coordinates are for the food are saved in a string. So the first thing and the first function that is called upon here is the make food function, which will create a position for the food. Let's jump into that one, I guess. Here it is. So basically this function is creating a new random position for the food, which is inside the playing field, and it checks if the player position is at this position. If the random position is on the snake character, we shouldn't do this. We shouldn't take this position. So then we try again until we find a good spot for the food, basically. And yeah, we have a bool variable called need food. And since we already made a food at the start here, we start the game with not needing any food. And so then we go into the game loop here. So it says as long as the player is alive, we should keep playing. The first thing this in this game loop is it checks if the player has inputted any has made a movement input. So the console key available checks if there are any inputs available to work with, and if it is, if there are, we should go and go ahead with this code block. And this code block sets the last pressed key variable to whatever key we pressed, and then we have a move player function that is kind of not a good name for the function. This can be better, but this one will do some things. Let's see here, move player. So basically, if we press the up key, we will change the y velocity to -1. So every time this loop ticks, we will be going ahead and putting our head of the snake -1 in the y position. And since the y coordinates are written from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we will be walking up. And you can't do this if you're going to the other. If you're going downwards, you can't do this. This doesn't work in the snake game. So unless, so if we're not going down, we can do this little thing. So this works for the same way as the others. So we're going to, and it's also, if we're going to the right or the left, which we will be doing, if we are able to walk up, we need to stop going this way. So we set the x velocity to 0. And it saves this in the velocity array and returns it. So then player position x will change to whatever the x velocity is, and the y position will change to whatever the y velocity is. Then each time we go after here, we're gonna look if we need some new food, which we checks in the found food function. And this says that if the player head is at the food position, we found the food. And we return true, we found the food, otherwise it will return false. Then we have this if statement that checks if, so if we need food, then we're gonna make some food. And I already showed you that function. And say that we don't need any more food because we just made one. The player length will be incremented by 1, and the score will increment. We will play a beep sound. I think if there's anyone who will be trying out this game and you don't have a PC, I don't think you can work with this overload. So you have to change that or delete the beeps. And then it checks if we have taken 5 fruits or 10 fruits or 15 fruits, we will increase the speed and the difficulty. Then we are updating where the player is. Like, let's see, get player position. Yes. So however long the player is, -1, we will we will do this for loop for how long the character is supposed to be, and we will start from the bottom of the index. and if we're at the head, this one will write out whatever coordinates the head should be in. But before that, if the y is more than 0, if we're a body part so that's coming after the head, this body part should be whatever body part was the position of whatever body part came before it. So this way we can keep track of the movement of the player. Then let's see, we are checking if the player is alive by doing the crashed function. It checks wall collision, and I don't think here we can see why I made the player array as a string. So the way I'm handling x and y coordinates is by splitting these strings. First by using the space character. This gives us a new array with first the x position, and the next step in the array is the y position. So then we can see here we're checking the wall collision. If the x position is 0, then we are in the wall. If the x position is the playing field with -1, we're also in the wall. So this just says, are you in the wall? We're gonna play some beep sounds and return false. This isn't very logical because we did crash. We shouldn't return false. But what this returns is the value that is needed for the player is alive. So yeah, that's one way to do it. And it also checks if the head is inside any of the other parts of the snake, because you can't run through yourself in this game, because then you will die. Basically, what happens next is what happens next? We clear the console, and then we write out score and speed. And then we have two functions working with each other. We have the print playing field that will need a playing field to print, and we get this with the get playing field function. So this just uses the width and the height of the playing field and makes hashes or spaces depending on if it's a wall, x and y position or not. Then we add a player, and we say that if we add the player backwards, because if you run into yourself, you need to print the head last, otherwise the head will disappear and become a little O. So this one puts the snake character into the playing field array, and lastly we print some food. And if we print some food, and if we just ate the food, we will need to make this food position a snake head, otherwise the snake head disappears. And last but not least, we print the whole field, and I added the food position to be able to write out the fruits red. Yep. That's basically it. Yeah, well, we got a important part of the game. So the game, how fast the game progresses is done with a tread sleep. We start at 400 minus the player speed times 40, so we start at 360 because we start at speed 1. And then this one will multiply, the play speed will multiply by 40 and take this away from the tread sleep. So the game will be faster and faster and faster. And then we have a little death screen that just prints out you crashed. Then it waits for 3.5 seconds and checks if the high score is higher than the score. We're gonna put the high score as our current score. And then we do it all over again. We return the high score. And then we're at the start. Yeah, that's my way of doing the snake game. If you watched this far, thank you for watching. I will be posting my GitHub link in the description, so you can download this and make it better, or just play the game. And yeah, that's that. See you next week.